Hello, this is Dr. Jack Jackson, and I am here with you today to start a new unit in the calculus playlist, or a new playlist for calculus. And this is the first unit in my Calculus 3 class. This particular playlist is the 12th playlist in my uh, selection of calculus playlist here on my YouTube channel. So I'm going to call it Calculus Unit 12, but really it's Unit 1 in Calculus 3. In this one, we're going to talk about new types of functions, parametric, multivariable, and vector functions. And we're going to talk a little bit about um, what these kinds of functions are. We're going to mainly talk about pre-calculus concepts for them, along with limits and perhaps a few other calculus concepts. So to get the ball rolling, this video is going to be about an overview of calculus, everything that we've kind of done so far, and a little bit about what's coming up for the rest of Calculus 3. So let's think about this just a bit. Where do we start with calculus? Well, actually, we start with calculus before calculus. We start with pre-calculus. And pre-calculus is all that K-12 mathematics, arithmetic, geometry, algebra, trigonometry, all those classes that we may have taken K-12 and maybe the first part of college before we get to calculus. They basically deal with a lot of different properties of real valued functions of a single real variable, among other things. Now, what makes it then calculus? Okay, if you think about it, the one fundamental idea that underlines all of calculus is the idea of a limit. It is the foundational idea supporting all of calculus. And what we do is everything in calculus really is taking some kind of pre-calculus concept and applying a limit to it. And once we apply a limit to it, then we have calculus. Every bit of calculus, if it's really calculus, is a limit of some kind, or at least there's a limit some kind somewhere back in the background. Now remember, there are two main branches of calculus. What are they? Well, the first one that we study is differential calculus, derivatives. And what do we do with differential calculus? Well, we define it. We look at approximations, formulas, interpretations, applications. And differential calculus, basically a derivative is a rate of change, an instantaneous rate of change, or it's a slope of a tangent line. It has something to do with changing. The other main branch, of course, is integral calculus, looking at definite integrals. And what do we do with definite integrals? Well, again, we do definitions, approximations, formulas, formula manipulation, applications. And integral calculus integrals arise from studying areas and accumulations. So differential calculus is the language of change, rates of change, and integral calculus is the language of accumulation and area. Now, at first glance, these two may not see the same, but then the fundamental theorem of calculus basically connects those two and tells us that those two things are in some sense opposites of each other. And so we could do this. Now, then, if all of this is applied to functions mapping a single real number input to single real number output. And this is what I would call calculus part 1. Okay, calculus A, we might call it. Okay, and actually, in most classes, the way it's divided up, this is all of calculus 1 and about the first half of calculus 2. Okay, so if you think about it, this is what we ended up doing. In the first half of calculus 2, at least when I teach it here at my university, we have techniques, more advanced techniques of integration, formula manipulation, and then some more applications of integrals, which basically sort of finishes off really calculus 1. Now, everything from that point on can be thought of as just building on this foundation that we have here and just extending this to new kinds of functions. So we're going to apply this now to different kinds of functions. And this makes what I would call, say, calculus B, or the second half of calculus, which turns out to be the second half of calculus 2 and all of calculus 3. So if you're getting to my calculus 3 class, you've already had calculus 1 and 2, so you've already started on this journey as well. What kind of functions did you look at that were different there? Well, the main one that occupied quite a bit of time in calculus 2 was the study of sequences and series. And a sequence is another kind of function, not one where we just have any real number for input and real numbers for output, but the input has been restricted to only being natural numbers. And the output is usually just, say, real numbers, the ones we studied in Calculus 2. And of course, the graphs now, instead of like being curves in a two-dimensional space, they are now some isolated points. And then we also had one very important thing that we did with Calculus 2 that was kind of the one really big new idea in Calculus 2, separate from just extending what we did in Cal 1, and that was the idea that we could approximate functions, basically any function, with a polynomial function, Taylor polynomials. And if we sort of let that Taylor polynomial just have more and more terms to where it becomes infinitely many-termed polynomial, now it's no longer a polynomial, but actually what we call a power series. And you can represent functions by power series. And that was kind of a big new idea that we had in Calculus 2. Now, what about Calculus 3? Well, you may have started this part in Calculus 2 as well, but we will definitely be talking about this in Calculus 3 as well. Parametric functions. Parametric functions, the input is a single real number and the output is some ordered n-tuple of real numbers, like the output may be an ordered pair. And if so, the graph would be tracing some sort of curve in a plane where we've given the output is a point given as an ordered pair, xy coordinates, but the input is some other variable like time. So we're tracing some path over time. And so the point has an input of a certain time and output of the actual location. So the graph is going to be some kind of curve in a plane. Now we could also have the input being a single real number, our parameter, and the output being an ordered triple, and now the curve is traced in space. And we could extend this to higher dimensions as well. We did some calculus with those, perhaps in Calculus 2, and if not, we'll do it in Calculus 3, where we talk about derivatives, arc length, curvature, and some other things there with that, and of course limits. Now, we also have two main kinds of functions that we're going to be looking at in Calculus 3, in addition to parametric functions. We're going to be looking at multivariable functions. So the input on those is an ordered n-tuple of real numbers and the output's a single number. So if n equals 2, then what we're saying is we're given an ordered pair, an xy coordinate is the input, and the output is another coordinate, say a z coordinate. Now if we were to graph those, then what we get is a surface in 3 dimensions. And we could extend this to higher dimensions as well. The input could be an ordered triple and the output's a real number, or the input's an ordered whatever, how many terms, n-tuple, and the output's a single real number. Now, one of the things that we're going to be doing with this, we'll do all the pre-calculus stuff. We'll do graphs and formulas and tables and so forth. We'll talk about limits, and then we'll talk about derivatives and integrals. And it turns out there's not just one derivative, there are actually infinitely many directional derivatives. In particular, there's one for each direction, each dimension, that are called partial derivatives that are going to be important. So we'll have a whole chapter in our textbook and a whole unit on basically multivariable derivatives, partial derivatives. And then we'll also have a whole chapter in the textbook, a whole unit of the course on multiple integration. And we see what we have to do there to make sense of integration in that case. And then probably the biggest unit on the course is vector functions. So this class is mainly about multivariable functions and vector functions. So there's sort of at least 3 different types of vector functions that we might consider. There are vector functions where the input's a real number and the output's a vector. There are vector functions where the input is a vector and the output's a real number. And there are vector functions where the input is a vector and the output's a vector. And we'll look at these things. We'll look at different applications. We'll look at graphs and formulas and tables and limits, and we'll talk about what kinds of things we can do in terms of integrals and applications and derivatives. And there are going to be some variations on the fundamental theorem of calculus in that context as well. And that's kind of where we're going to shoot for that towards the end of the semester. So that's kind of how calculus stacks up, if you want to think of it that way. Now, on my playlist, on my earlier playlist, the Calculus 1 playlist are these first 7. And there's sort of many different orders that you can actually go through Calculus 1. This is the order I've chosen to do in my class. If your class does a different order, you can jumble around the order of these playlists without too much trouble. Um, but this is an order I like to use. The first unit is on limits and some pre-calculus concepts. That's my playlist 1. My playlist 2 is talks about the derivative, but in that case we do definitions, concepts, interpretations, and approximations. But we're only focused on those main ideas without getting bogged down with formulas too much. Then we do the same thing for the definite integral. We do definitions, concepts, interpretations, and approximations. And again, we're not getting too bogged down with formulas, but get the understanding there. Uh, so in derivatives, when we talk about approximations, we're talking about working with difference quotients and symmetric difference quotients, approximating from a table and a graph and so forth, or a formula. And the definite integral, we talk about different um, approximations. We're talking about left and right Riemann sums, midpoint rule, trapezoid rule, Simpson's rule, those sorts of things. We do those in Cal 1, at least I do. Um, then we go back now to the derivative again in our 4th playlist, and now we're dealing with algebraic shortcuts. You could certainly do that before you talk about integrals at all, but I like this back and forth on derivative integral, derivative integral, derivative integral for a while. So unit 4 for me is talking about the algebraic shortcuts. So we develop all those and get good at formula manipulation. Then we go back to integrals in unit 5, and we talk about some introductory integration techniques. So just real basic integration using the fundamental theorem of calculus by finding some formulas for antiderivatives. So we basically took what we learned in unit 4 and learned how to reverse that. And it is that's our basic technique. So that includes integration by substitution, which reverses the chain rule for derivatives, and then also integration by parts is also covered in that one. In unit 6, there are different. Now we get to where we're kind of wanting to go is to do some applications. The big ones there are just basic derivative interpretations, optimization problems in various contexts, including some business applications, science applications, a bunch of different ones. And then related rate problems are another big class of problems in that unit. In Unit 7, we do some introductory integral applications. In Calculus 1, I like to at least get a little bit taste of where we might use integrals. This includes a few things such like as areas under a curve, areas between curves, so a couple of economic applications that you would normally cover in a business calculus class, like total value of an income stream, present value, future value of an income stream, consumer surplus, producer surplus, a few other different applications like that, average value of a function, a few things with that. And then I have a playlist that's just Calculus 1 Review, which is really just pulling together all the review videos from these earlier 7 units. Now, my Calculus 2 playlists start there with playlist 8, 9, 10, and 11. Playlist 8 or Unit 8 is more techniques of integration and anti-differentiation. And when I do Calculus 2, I actually start by reviewing some Calculus 1. So I quickly review some limits and differential calculus together, and then we actually go back over, but fast, units 3, 5, and 7. Well, 3 and 5, and then 5 leads directly into 8 for more advanced techniques of integration. So we spend quite a bit of time there. And then we kind of review Unit 7, which leads right into Unit 9 on more integral applications. And the more so the more techniques of integration, that's going to include things like, partial fraction decomposition, trig substitution, trigonometric integrals, and some different types of integral techniques that are useful. Unit 9 is more integral applications. That's going to include lots of things like, work problems, volumes by slicing, volumes of revolution, some centroids, some various other applications. And then, as I kind of mentioned earlier, sequence and series becomes a big chunk of that course. And then sometimes if we have time left, we'll get to at least a little bit of Unit 11, some parametric functions and conic sections. But if you didn't get to that in my class, it's not too big a worry because we're going to actually pick that back up as we go forward in Calculus 3. So in Calculus 3, the way I've got it set up is this playlist, which is on new types of functions, parametric, vector, and multivariable, but mostly is going to be pre-calculus, a little limits, and maybe a few actual calculus things, a little derivative and integral applications, particularly of parametric ones. So this will go back. So the Unit 12 will kind of include, well, my Unit 1 in Calculus 3 will include this. We'll actually start here with this Unit 12 here, and then at some point we'll go back and pick up Unit 11 too, just in case we didn't get that covered well in Calculus 2. Then Unit 13 is with partial derivatives. 14 is multiple integration. Those are our second and third units in Calculus 3. And the fourth unit's our biggie on vector calculus. In the, oh goodness, it's coming. It's getting close to, it's getting close to what, 40 years now that I've been teaching calculus. Not quite. But in the last 27 years, actually more than that, in the last 30 years, I've only used three particular textbooks: the school here and where I was before. Um, Always used one of these three textbooks. There's one by Larson, one by Stewart, and one by Hughes Howlett, Gleason, McCallum, and others. So these are the three main ones, and these three textbooks are the ones that I probably influenced these notes and these videos and so forth the most. And here's kind of a playlist, a breakdown of the units in Calculus 3, along with which YouTube playlists we're talking about, the topics that we've kind of already discussed, and then what text chapters they are on these various ones. For example, this semester that I'm recording this, we're using Larson's text, and these are the chapters that'll be included in those units here. When I did it last time around, I think we used Stewart, and there we have it, the Hughes Howlett, Texas, those units. So some similar kind of layout, but not exactly the same. So basically, Calculus 3 extends the ideas of Calculus 1 and 2 to new types of functions. So one of the big questions, or actually the big question that we're going to be asking ourselves all semester is, what pre-calculus and calculus ideas can stay the same, and what concepts need to be tweaked a bit to work in the new context of these new types of functions? And that's going to be the big question we're going to try to answer. And it's going to follow the development of pre-calculus and calculus 1 and 2. So we're going to start with pre-calculus ideas, tables and graphs of functions and so forth. Next, we'll apply limits. Then we'll apply derivatives, then integrals, find the fundamental theorem of calculus, and then do this for various types of functions. All through the class will be, when I teach Calculus 3, I kind of review Calculus 1 and 2 along the way, especially Calculus 1. So whenever we want to talk about limits in, say, multivariable functions, we'll review what does a limit mean in single variable functions. And it's okay, now how does that, can that be translated to multivariable functions? What needs to stay the same? What needs to change? Do the same thing for derivatives. When we get to multivariable functions and we don't talk about a derivative, what would a derivative mean in this context of the new function? We'll first redefine or remember the definition of a derivative from calculus 1. We'll talk about how we approximated, how we computed with it, and then we'll say, okay, now how much does that transfer over? So we'll always go back to calculus 1 and touch base on the basic idea and review it before we go on to the new one. And that's kind of how these little playlists are going to go. So hopefully that gives you a nice little overview of calculus, of where we've been, where we're going, what you can expect to see out of Calculus 3 and out of the remaining playlist in my YouTube channel as we go through this calculus sequence. Hope you enjoy.